All right, hey everyone, welcome to another deep dive. Today we have with us router protocol. And you are Shubham.
Sure.
Yeah, no, that's hopefully I got the pronunciation right, but super happy to have you here. You had just told me you were one of the founders. Why don't you when did you kind of start this? How did you get into doing cross-chain interoperability?
So, hi everyone, first of all. How I got into um, interoperability, right? So, as I have a background in computer science, I have been in crypto since 2016, solidity enthusiast. I did couple of things before this, which is what led to this, to be honest, right? So I figured problems when Polygon was launched early days, where it was trying to bridge the assets with a latency of around 45 minutes from Ethereum to Polygon and 3 hours in reverse, right? So I figured, let's say we envision for something like decentralized internet, right? And I know that one machine cannot solve it all. So, and if I take these decentralized networks as decentralized computers, now I have computer with one capability. Let's say Ethereum. It's a Turing machine which is decentralized and optimized only for certain things, right? I can execute bytecode, but within a constraint. Now, let's say I have a specialized machine, chains which are specialized for storage, chains which are specialized for security, right? Privacy. Now, so I get to a state where I have different efficient systems, but I still cannot develop a efficient solution utilizing all these systems. I cannot have that level of modularity or flexibility that I have in Web2 systems. So now how you fix that? How you fix that without breaking the assumptions in those individual systems, right? So the vision was to have a standardized rule to interoperate between these layers, where I can move my asset security to Ethereum, and I can move my game economics, game related compute to chains like Solana, which gives me better TPS, right? How can I move my economic value to Bitcoin while keeping the contracts on Ethereum? So when you try to achieve all this, right, you'll think of like there has to be a solution where I can utilize both of these strengths, and you'll jump to something that will be interoperability by keeping it decentralized. So that was the core genesis of it, like slowly working with different projects, having that Web2, Web3 background. I figured that this is a natural path towards decentralized internet, maybe.
Cool. Yeah, well, we can kind of get into how it works a little bit then. So yeah, I'm just gonna pin myself so people can see the whiteboard a little bit easier. And then what would be like the ideal use case for router? You know, like if we're gonna walk through an example, what would you say is like a classic, maybe like a cross-chain bridge, or would it be like more of a trade app or something like that?
So we'll start with use cases, for example, right? I'll start with a simple use case. First example is, let's say, asset related bridge.
Okay.
So recently we have come up with a new fundamental that we are calling reverse verification. So let's say I have a standard protocol which has source chain, destination chain, and a message passing layer, right?
So like let's put it over here. So if this is like Ethereum and then Polygon, right? These would be two that you could do this on, correct?
Yes.
Okay, so we have ETH over here, and then we have Polygon. Okay, so how do the two talk to each other? Normally, yeah, okay, I guess we want to go from there.
The marker faded actually.
Yeah, no, I grabbed a different one. We'll outline it. Polygon, Ethereum. Okay. Yeah, so how would these two networks, I guess, use router protocol to talk to each other?
Okay, perfect. Let's start with that. So I know individually Ethereum is decentralized, right? I know individually Polygon is decentralized. Now I want to bridge them. I want to ensure that the connecting layer should be also decentralized. So you figure out how you want to decentralize that. There are multiple ways to do that. Simplest of all is a blockchain, right? It's nothing but a set of semantics which forces you to coordinate better, right? To take decision with consensus. So we added a POS chain in between, which is by genesis of it is interoperable. So let's say there is a POS chain
Do you
which acts as,
what's it called? Is it called routes, or what's the name of the chain?
let's call it router chain for now.
Router chain. Okay.
Yes.
All right. Sounding fun so far.
So now you have a decentralized network which is composable, right? Now what I do is, while designing this network, I'll say, okay, you can understand whatever is happening on Ethereum, and you can also understand whatever is happening on Polygon. Let's say I can listen to a contract on Ethereum and I can listen to a contract on Polygon. We'll call it gateway contracts.
So would these be, would these be like light clients of the systems?
So this is a Cosmos-based blockchain itself.
Cosmos-based what?
It's a Cosmos-based blockchain.
Yeah, no, but I mean like of Ethereum. So what are you coming to? So like ideally to bridge these two, basically like you would need to know like a traditional bridge, I guess you would have, right? Like this guy over here, he wants to bridge USDC from Ethereum to Polygon, right? So he would deposit USDC over here. And then what needs to happen over here is that this needs to mint, presumably the same guy, maybe could be a different guy if you want anonymity. It needs to mint this guy USDC over here. Yes. But the hard part is how do you know with finality that this happened, that he locked this, right?
So I'll tell you. So router chain is divided into three components. One is orchestrator, which listens to all the chains it is plugged to. One who relays to the target network, that's called relayer, and the chain itself. So we have a set of orchestrators which are run by validators themselves. They have an entry that, okay, you have to listen to this contract. Let's say you are transferring USDC. Now USDC, you cannot just go and to your MetaMask and say transfer to this address and it will be transferred to different chain. Now you need a mechanism to tell that this USDC needs to be transferred to this chain to this address, right? For that, you need a contract. We call it the bridging contract. Now a bridging contract calls the gateway contract, which tells that, okay, this has to be relayed and this is a trusted party. This contract is trusted. You can relay the information. On the source side, we have logged the funds.
Yep.
And there's an event corresponding to that deposit, which says, I have made the deposit respect to this address and I want my funds in this chain.
Cool.
That's the message processed by orchestrator and written on the chain. Now, all the POS validators votes on that proposal that, okay, if everyone gets the same proposal, if 2/3 of my majority gets the same proposal, I say, okay, we are good to relay it on the destination side.
Okay. Again, so this is a Cosmos, this is Tendermint.
Yes.
And then so like if 2/3 say deposit happened, then you can mint, right?
Yes, then you can.
So I guess all of these orchestrators then would be running presumably like a full node over on the Ethereum side.
Right? Yes. They'll be running a full node. Now, On router chain, I have a state which says that consensus has met, you can start the outbound call. Now in normal bridging, what happens? You have one inbound which directly translates to outbound, right? The logic of transmission cannot be interrupted. It cannot be manipulated. In router's case, we have another fundamental chain, which is middleware. Now on router chain, you can write an intercepting logic. It can be a middleware. Let's say simplest use case of this is I have USDT, which is 18 decimal maybe on Ethereum and 6 decimal on Polygon. If I don't have a layer in between where I'm writing this logic, this conversion that 18 should be converted to 6, I have to write either on the source contract or destination contract, assuming that I cannot change whatever these nodes are doing, right? Now I need to have that composability in my middleware. So that was added, that you can deploy COSM-WASM contracts to intercept an inbound and initiate another outbound. Another use case of this thing is, let's say multiple asset bridges are built on top of router, covering different chains. Let's say there's bridge X on top of router, asset bridge on top of router, which connects Ethereum, Polygon, and BSC. Now there is another bridge which connects BSC and Avalanche. Now I want to go to Ethereum to Avalanche, right? So the half signal will flow like, okay, I just want to go till router chain, and then figure out if there are other bridges which can connect me to the different chains.
So this is the third piece, or this is just separate?
This is the part of middleware.
Oh, okay. So you could use a different bridge if necessary.
Yes. In the middleware, you can, it's just a use case of middleware where you, whatever compute you want to offload to your bridge, that like fee reduction, like
sure.
Like rerouting in case of lack of funds, right? Like initiation of refunds, all that logic can be written on the middleware.
Thanks. All right.
So now we are at a state where the asset transfer message is at the middleware layer. You have performed your middleware logic. Now you trigger an outbound request, which goes to destination chain. Again, all of your validators signs on the same consensus that this data is ready to be executed on secondary chain, and you relay that message, and verification happens at contract level and tokens gets minted.
So this would be the last piece, is kind of the relay level, you could say?
Yes, it's a relayers.
Relayers. And then I'm guessing that works by basically, is this a permissioned role over here?
Trustless.
So anybody can basically grab these 2/3 of signatures and they post them here?
Yes. So router chain does one thing beautifully, is it curates a message and binds both the things together. You have the signatures and the message directly from the router chain. Any relayer can go and read it from router chain and push it to whatever the chain.
So anybody would come. So after 2/3 of deposit, then they say mint, and they make, like, you call it a proof of some sort, and then there any relayers
can go and relay it on destination side.
Yep. So they would push it over here. So cool. All right. I think I got it. So then you would have the orchestrator. So the orchestrator are those, that's kind of your proof of stake network in general.
So no, orchestrator is a listener network. My proof of stake network is, you may call it that orchestrators are tightly coupled with validators. So yeah, it's part of proof network.
Okay, so but it's technically different people, I guess.
Yes.
You could say. Okay, technically different people. So orchestrators come and they push it to the validators, who validate it, and then the relayers sort of grab it and push it over.
Yes.
Cool. All right. So I guess the question I would have, so like, what's So some things would say like, what's to prevent these guys from like the validators? Could they like make a false claim, not push it to router chain, like with their signatures, and then just like push it over to Polygon to mint a whole bunch? Or could somebody grab that and push it back to router chain?
No, that cannot happen. That cannot happen. So we use a checkpointing mechanism on the destination side. It basically tells you that it has to be subset of these number of signers, these many signers, and it has to cross that threshold of verification. So even if you have consolidated a proof, if it's a fault proof, right, it won't work on the destination side, because destination also knows of signers. Whenever there's a signer added to the network, a checkpoint is added to the destination contract, to all the contracts.
So with this proof, you also have like checkpoints created almost. Okay, and this is basically, this is the list checkpoints. These are like the list of signers, right?
Yes, these are the list of signers, and my contract knows that these are the subset of global signer list.
Cool. Okay, so then I guess, one of the hard pieces with any of these blockchain bridges is like, how do you guys deal and how do you guys think about finality on it? So, like on Ethereum, like we all know, like technically it's fine, like it's usually final really, really fast, but technically like they could do a hard fork and pull away. Like, is this just something that you would have to deal with, and or would router chain sort of slow down if there's not finality on a chain?
So this is like one problem that we have been thinking quite a while right now, right? So, and I feel when there are different systems which run with different consensus, right, and to derive one consensus which agrees with all. So in worst case, you have to take worst of all the chains.
Yep.
That's worst of all the chains you have to take, right? So I believe for now, waiting for that finality, whatever that safe block is, right? Now I'm not storing all the cascading states of the source or destination blockchain. And if there's a hard fork that happens, right, I lose all the states.
Yep.
I believe these things you can sort of like try to tackle with things like insurance and all. But technically, I still did not find one plausible approach to solve this. There are theses controlled, better delays. I'll have restrictions. I'll have network restrictions. But I feel all those things are nothing but impacting decentralization. It's like having superpowers. Decentralized systems doesn't have superpowers. So I feel like that's just patchwork we are trying to do. But again, in our setup also, there will be things like we'll wait for excess blocks, we'll do variable consensus. So you can decide for a transaction how many blocks you want to wait for finality.
Oh, cool.
It's me deciding it.
Nice.
So that I don't have to take that overhead and be accountable for that. It's you who decided for this.
Yeah.
So for fast transaction, I can go something like 2-block confirmation, to think of applications like cross-chain perp aggregation or any sort of cross-chain onboarding which requires very low latency. I can leave it up to you. Whatever confirmation you want, I can relay that.
Nice. Yeah, I mean, that sounds really good. I think the other piece too would be, do you guys maintain any forkability in your chain? Like if you guys wanted to change anything.
So
could you
it's
do
like as any Cosmos blockchain, right? Where upgrade happens with governance, and forking can happen, to be honest. But I feel the network is more of POS. Fast consensus can be achieved, and I'm certain that it won't be as spread or as decentralized as the source and destination chain, as it's the connecting chain. I feel forking won't be that bigger problem, because forking impacts only when you have a stale part of network which is running on the previous state. and manage to append more blocks in your core chain. And you end up with two different network states. So you don't know which one to follow.
Right.
But
Well, I mean, like this would be like, do you guys, is there upgradability in this bridge contract over here?
upgradability is on both the bridge contracts, yes.
Yeah. Yeah. And I guess who would that be controlled by? Would that be?
So that will be controlled by governance, not
Okay.
by regulators.
Yeah. Because I mean, that's like sort of a tough part with decentralization is, how do you, if you maintain any sort of upgradability here, then it makes it tough.
Yes,
Because,
yes.
yeah, no, completely get it.
So we are working on one more fundamental actually. So think of a state where I can just listen to any contract, not only the new contracts which are trying to trigger events through my gateway. If I can just listen to any contract.
So like if you would have like a state proof of Ethereum going here or something.
No. So
no, okay.
Think of it like this. Let's say there's Uniswap, right? And you are trying to observe a price of Ether on ETH-USDC pool. Now each price is $2,000. You just want to listen to that event. Now there's no day Uniswap will upgrade its contract to call any of those bridges and emit that event to those bridges.
Right.
Now my chain is not listening to each and every, my interoperability layer is not listening to each and every contract out there, right? Now, what I can do is I can set up a rule on my middleware that I'll allocate this amount of funds to listen to this contract for this time span. Can you continue doing that? Now, all the orchestrator will start listening to that, and
oh, cool.
will vote on that even.
So basically, like instead of just the bridge contract, what you could have is this could be just like or any contract, and then you just tell the orchestrator like, hey, don't listen. You can listen to the bridge contract too, but go listen to Uniswap for the ETH dollar price, and then pass me over the ETH dollar price so I know, so I can use Uniswap v3 as my oracle or something.
And this gives me one more level of composability. Now I can have self-triggering contracts where I can have rules and I let these events be the trigger of that. I can just subscribe to an event on source chain and I can create inbound and outbound rules to make the whole process automation. And the very fit use case for this is rebalancing. Let's say I don't have minting privileges of an asset, right?
Right.
And then skewness of liquidity. Now I want to rebalance. I need some trigger of rebalance. Either it has to be a Web2 system, which is continuously monitoring and trying to rebalance, or it has to be an economic driven rebalancing where I change the fee on both the terminals and then there's a natural flow of money to gain that fee. Or the third perspective is I should have a decentralized process which is doing it, right? Now, let's say I start observation of my contract, some XYZ bridge contract, that, okay, look for balance of this particular contract for this particular asset and till this time frame. Now, whenever this event comes on the source chain, middleware logic will be triggered and rebalancing will be checked. So now there's no human intervention happening, right? Unlike other approaches where how you interact with blockchain is a EUA has to trigger something and then something happens. Now I can just listen to any action and take certain actions on destination side.
Nice. Yeah, no, I like it. And then because the relayers, and then they can do custom calls too, right?
Yes, exactly.
Yeah.
They can.
So then you can either say just push it over to the bridge contract or do.
Yes, I can just create a loop. I can create a loop. I can, the moment I deploy this middleware, which says, okay, you can listen to any damn contract. I have listened to Uniswap, decided to go long, maybe on some DEX on Polygon.
Yep.
Through a contract and created another inbound to middleware again and creating this loop. Now, all I need to have is sufficient gas in my middleware contract and this loop will continue. Now
So
this,
it's like you could do like flash loans from there over to here or something. And
you can do arbitrage. I
yeah,
can literally do arbitrage from source and destination. I'll go and check price. I'll do arbitrage.
yeah, no, that's cool. That would be
Another thing that we were thinking of, right? So what I believe is how HCI evolved, right? Human computer interaction. There was a time a human was continuously interacting with machines, wires, buttons. Then a next evolution happened where you had cron jobs, scheduled jobs, right? Where you are not continuously monitoring, but something is invoked at a particular time span. Now, a further evolved version of that is automation, and then maybe better human computer interaction is through intelligent interaction, whatever is AI ML right now, right? So I believe if its ambition is to become a decentralized computer of world, the blockchain has to evolve to that space where the automation itself is decentralized and there's not much human intervention all the time, and you can achieve such use cases.
yeah, no, this is I think my last episode was a couple weeks ago. I had on Autonomous, who was decentralized AI, sort of, which was very, very similar with the bots that could call the different contracts and automate the DeFi trades. Yeah, no, this is cool. I think my one question I had with regards to the bridge contract, when this bridge contract you deposited here, the rules for withdrawing it, is it just basically you need 2/3 of the router chain signatures?
For now,
Or is it more like a roll up as far as there's logic embedded as far as what can happen?
no, so for now it's 2/3,
Yeah.
2/3 majority, but we have one more module. It's called ASM, additional security module. Now you can have another layer of security on top of this. And let's say you want to route your contract so that parallel to 2/3 majority, you should be able to do that.
So like an ASM will be like a wrapper over this,
Yes.
and it'll say this plus a multi-sig, for instance.
Yes, this plus multi-sig, for instance. So let's say ASM won't be wrapped here because verification has to happen on the destination side, right?
Right.
I figured a way to go through 2/3 consensus. I'll also figure a way to have that 2/3 signature and have that ASM module on the destination side to validate that rule.
Right. So you would have the ASM over here.
Yes.
And it would validate that. So would it be a check on top of your 2/3?
Yes. A secondary proof generation and secondary proof verification.
Right. Cool. And is that what do you tell, like, so for instance, is this custom to you guys, or would this be like per token? So like, if the teller token, for instance, did this, or or USDC, would you try and have this be run by like the USDC team, or would you guys run the ASM?
Anyone who, let's just, simplest example is someone is trying to build an asset bridge, right?
Right.
So he can just interact with USDC token. In his dApp, it should be added, not on the USDC token.
Right. Yeah. Yep. Okay. Cool. Yeah, because that's like I was wondering, like there's the problem I've seen with like a lot of like client bridges too, is that like if these 2/3 depositors, they're over here on the router chain, they could just sign like any arbitrary message and push it here. Right. It wouldn't necessarily have to be validated by the router chain. Sort of because like it's back to the you couldn't tell if router chain forked or not. Like they might not slash themselves even if they wanted, because like and I guess that would be, it goes back to a different question, like is there any sort of limit on the asset size? Because like like right now, like let's say router chain, I actually have no idea what your guys' market cap is, but like if your market cap is like say $100 million, is there a limit to how many assets can possibly be bridged and have this be safe on all the chains?
Yes. So through our official bridge, there will be a cap, daily limit enforced at contract level. But if someone is willing to build another bridge on top of router chain, right, I can.
Yeah. Okay,
So
cool.
the limit if you go through router's asset bridge.
Nice.
So I'll try to touch upon one more thing that we are exploring right now, given we are talking, right?
Please.
So
Yeah.
we are calling it reverse verification. So now we have discussed about security, which is good. Now, to get to real use cases, we have to talk about latency, right? Because if it's an asset transfer, perfectly fine. But if it's a contract call, most of the time it's probabilistic, not deterministic. You will never know the state of your destination chain, right? Now, what happens? You guess the state and you take actions. The state might be different than what you thought.
Sure.
For example, simple arbitrage. I want to convey the message of arbitrage through communication layer, right? It will fail. It will fail to perform to give you results, right? Now, what we have done is think of a model where there's no latency. You give money on source side and you get money on destination side. There's no orchestrator, validator, relayer, all of that. If there's
So this
nothing,
one must be like optimistically doing it. Right.
yeah. So you do it and then you validate whether whatever you did was right or wrong. So how you do it? Let's say I have a payload. I told I want $100 of USDC on this chain. I generated one message. There's one forwarder, if we may call it, right? There's one forwarder listening to this event. That, okay, this guy needs this money on destination chain. He'll just go and give that money. Without thinking much, he'll go and just give that money and expect to get that money back with some fee. Now, how he will get that fee back, right?
Yep. Yeah. No, I think I get where you're going. I'll let you explain it though.
Sorry.
No, continue, please.
Yeah. So on the source side, you have a commit. On the destination side, there's someone who gives you the fund. Now, on the destination side, I initiate the reverse verification. I initiate the whole verification process. So on the source side, my transaction is at a state where in the middleware contract, I have one message says, I got the funds from this source on this chain. On the destination side, there is a message initiated to middleware which says, okay, someone paid this much fund for this address. If you can match both the hashes, you should initiate the refund. So I get the funds instantly, but the forwarder, which doesn't care about latency much, for an amount of fee, will be able to fulfill this order. And I can reverse validate whether he paid to the right actor or not.
Yep. So this would be like, like in the bridge example, somebody would come and they would deposit USDC. I'm running one of these reverse validators. I just give them the USDC and then I'll wait through this whole process basically.
No.
No, I don't even wait through this.
So you have paid the amount, right?
Yep.
I'll start a bridging from your side. You will not wait for the cycle to finish. You will instantly hit the router chain, check the middleware. If there's a source deposit, you'll get it on router chain directly. If you want it instantly, else you wait on the destination side for funds. So I'll tell you, there's one issue with the second approach that you mentioned, right? So let's calculate the gas we have to pay in all the interactions. Source side, we pay depositing gas. Destination side, we pay signature verification gas, right? Which is huge. For chains like Ethereum, if you do around 60-70 signature verification, it will be around 700,000 gas, which is very costly. Now, what I'm doing is
that's like what, $200 or something at current gas prices, or
yes.
Yeah. Okay.
So what you are doing is you are initiating an inbound from source and you are initiating an inbound from destination, and it's resolving at middleware layer. So you don't have to do signature verification in either of those contracts on source or destination. It's like an inbound.
Okay, so the USDC would get passed right from here. It would basically be like a transfer of USDC from, he sends it to the contract, it gets sent to the guy who released it over here.
No.
No? Sorry.
So it's a bit complicated actually. So I'll try to.
Yeah, I guess how does the USDC guy, the verifier, he gets paid on router chain?
Yes. So now we have this proof that router chain can hold state, right?
Okay.
In middleware contracts. I have accounting on the middleware contract that, okay, this source has deposited 100 USDC.
Okay.
And I have a message from destination that this forwarder has paid 100 USDC to this depositor.
Okay, so you guys are basically holding the USDC in router chain then, right? Or
it's not the USDC, it's proof of deposit.
sure.
It's held by the forwarder itself. Like forwarder has a control on it. If there is a right forwarder who takes the right action, he'll have the money.
Yep. And then he could take this money here on router chain and bridge it out where he wants.
Where he wants to.
Right.
So
Okay.
it's like you can aggregate, and so now for every inbound, I don't have to create a outbound on destination chain, which saves a lot of gas with overall interaction, right? And in our recent analysis, we were able to beat almost every bridge out there in terms of gas optimization. Like,
nice. Well, because I guess, if everything goes through here, then like technically if everything works this way, you actually have no signature validations, right?
No signature validation. I'm just using economic value to act good. If your instruction is not executed the way I want it, you'll not get your money back. If basically I'm signing the whole thing, I'm creating hash of the source instruction, and I'm expecting you to relay that hash on the destination. If you do it correctly, you will have your money plus commission back.
Yep. So it could be something like this was obviously a USDC bridge, but it could be like, go make this trade over on Sushi Swap. And as long as they execute it on your behalf, then
they get the refund, else they lose the money.
Yeah, I mean, how I guess would you? The obvious question here would be like when it comes to trades or any actions, like is there any MEV sort of problems with this? Because you're obviously like, this was the big problem with like the arbitrage bots that you're building. It's like you have a very, very public strategy, that everybody can sort of see and front run you on. So
if you are sort of like interacting with applications where slippage is a factor, I believe risk of MEV is always there. Even if it's not a cross-chain message, you are directly interacting with the chain.
Right.
The risk is there. But if the actions are not prone to slippage, I believe this should function fine. Like transfer of assets and all, it should fine. Like even staking, lending, borrowing, especially for the swaps and all, it'll be a problem. But for other things, I believe it's fine.
Nice.
And MEV protection is not the area we are right now focused on, because I feel MEV has a great role to play in overall decentralization.
Yeah. No, I think that's cool. I guess, yeah. Another question, I guess, that comes up. What's sort of your guys' governance process, and where are the governance layers at? Because you had talked about there was sort of upgradability in this bridge contract and this bridge contract, and there's obviously some governance over here. So is your token native on Cosmos, or is it native on a different?
Native on Cosmos.
Native on Cosmos, okay.
So the governance is, we are using standard process provided by Cosmos. So even like addition of a new chain, incorporation of a new chain, whether with different uh, resolvers or same resolvers as EVM chain, right? Everything is done by governance. So you propose the changes. If it meets the majority, it gets merged to the original code base. It's like any EIP updates that you do. So at the chain level, the update is like that. For contracts, we are yet to figure out the exact thing that we'll be doing going ahead with. Initially, it can be a multi-sig, later on evolve to a more governance-driven process.
Cool. Yeah, and then maybe the last question. I don't know. I'm sure I'll come up with more. But what would be like the limits? So like whenever you're pushing, you have like all these signatures on a proof. How many messages can you sort of fit into? And how often do you do that? You know, like so like there, if a whole bunch of if the orchestrators grab 20 messages and you guys validate them all, do you push over like one set of signatures per message? Probably not. You know, how do you batch them? How do you think about?
So right,
timing on
recently we did batching actually. So batching batches is around 1,000 to 2,000 messages, if I'm not wrong.
Okay.
It's configurable parameter that we have on orchestrators. So we batch on source like 2,000 transactions.
So then how often would that be? You know, like how often do you actually do it? And because that obviously would affect the bridge speed, or do you push most people to do it this way? And then you're not.
That way is still very experimental. We are
Okay.
solid in the other approach. But this is more battle tested. We do it, I believe the block time is every 3 seconds. So we poll every 3 seconds.
Every 3 seconds?
Yes.
Well, you obviously don't do that on like if you're going this way from Polygon to Ethereum, you're obviously not checkpointing to Ethereum.
I'm not talking about outbounds, I'm talking about inbounds. So we read every 3 seconds.
Okay.
Continuous polling. For outbounds, it's so overall through the standard approach, overall time will be around 2 minutes is the average that we got so far, 2.5 minutes. So there's relayers playing a crucial role there actually. So we have also extended it to a state where user can go and directly erase transaction if it's in block state and relayer network is not picking up the transaction, right?
Oh, so okay, so like you would basically like you would hope that people would be tipping basically the relayers to push it at any point. Yeah.
In the overall fee dynamics, base relayer fee or basically cost to cover the overall transaction plus relayer fees added already. So it's added, but then users can top up more on top of that so that it becomes more lucrative for relayers to pick it up.
Nice.
Also that, so in the Explorer itself, you'll see in middleware state that, okay, your transaction is stuck because of less gas. You can just go and relate yourself. And through UI, you can just trigger that.
Nice. Yep, that makes sense. So cool. And then like if you relay yourself, you could get could you grab the reward for the rest of the stuff? Yeah, so it would be subsidized, I'm guessing. And then cool. And then do you guys have inflation on your token, or is that just where do you put it towards?
So we will have inflation in our token to reward validators, to be honest, right? But we are trying to figure out another way. We are not yet final with that, but I feel that that can solve the problem of inflation. We are not talking much about that approach, but once it's more concrete, we can start talking about that. And that will reduce our inflation by a lot. I'm assuming that you see around 10 to 12% inflation with validators of new chains, right? That's the minimum amount of reward that they'll expect. You can assume that it will be reduced to around 2 to 3%.
Yeah. Cool. No, this was I'll unpin you now. I guess. Yeah, what did I miss? What do you want to add to complete the router protocol vision, or did I do a decent job?
So did we miss? What did we miss? I believe our next focus will be to sort of like figure out if there are more better approaches to achieve consensus rather than linear model. We plan to explore for sparse model, because I believe the core question here is decentralization, not blockchain. Unlike others, we don't want to chase that dream of, okay, we want to do it using blockchain only. I'd be perfectly fine if we figure out a DAG structure to achieve decentralization with far more capabilities than any other blockchain has it now.
Yeah,
So
no,
that is one vision that we are focused at. Few more things about router chain. It's multi-VM compatible. You can deploy Solidity and Cosmos on both. We can add more chains, and it's compatible with sharded chains also.
so what would be the limit, I guess, to chains? Like the limit would be basically, because the more chains you add, like how does that scale it? Because like you guys basically would just scale, like it would be harder to run an orchestrator on all the chains, right?
So good question, actually. So we are working on one more model where we want to have chain specific validators.
Okay.
We want to further modularize it to a state where we can have app specific validators to sort of like reduce that bottleneck.
Well,
And
because
now-
right now, yeah. Because I mean, I could see that being an issue. Because right now, like if how do you add chains in the way that, like, does a validator have to validate every chain? Because like, you know, like let's say you added, you know, super shit
right
chain.
now, the things are like that actually. So
Yeah.
at least 2/3 of the validators should validate each and every chain.
Yeah.
But we are planning to sort of like revise that, and we are working on one fundamental where we can think of something like chain specific validators.
Yeah, because I would imagine that could get like very hairy as far as governance goes, and adding a chain, if not everybody thinks it's secure, it would be, you know,
Yes.
would you want to add it? So
300.
cool. And then where you've already gone into a lot of what you guys are working on, what chains are you guys live on now? And what's sort of in the near future for you guys?
So we have done it with almost a couple of EVM chains. Then we have done it with near scroll.
Nice.
These sort of things we have done with even few of the ZK ones, ZK sync and all we have done. So
And
we are integrated to variety of chains rather than like a number of chains. We are working on Solana integration. We are also working on Bitcoin integration. So yes.
Cool. And then, yeah, so I guess it could be trustless to sort of launch the bridge contract. You would just basically need you guys to pick up the orchestrator piece and listening to a chain, like if you wanted to deploy it on a new chain.
Yes.
And then nice. No, and then yeah, I know we're kind of wrapping up here on an hour. Like how has, I guess, since you've actually been building this for a long time, like 7 years now, if you've been doing this for, you know, like how has your view of cross-chain sort of changed or evolved over the past few years? You know, where do you think that the space in general, like what's been sort of mind-blowing and paradigm shifting for you?
So honestly, how I see it, right? So the start of blockchain was very good. So genesis of blockchain was to solve a fundamental problem, which was like economic security, right? Your money is your time, and as there is no visibility to inflation, you lose your money if someone inflates it, right? So you required a better currency which is more decentralized. So Bitcoin was well thought actually. But second evolution of that was Ethereum, right? So Ethereum tried creating a decentralized Turing complete machine. So now when we talk about that, I want to create a decentralized application, but can it scale, right? So can I assume that it's the most efficient version of it? No, I believe that hash graphs are far more efficient version of this. If you talk from computer science fundamentals, that if I want to have a linear consensus or sparse consensus, I'll be fine with probabilistic consensus than deterministic. If I can save some resources, and there's decent probability. Here's also it's game of probability, right? There's a probability that 2/3 of my validators will not collude. So here also it's not deterministic, it's probabilistic. But you're betting on that probability, right? I can achieve same by using a DAG. So I believe, so when in 2018 I had this thing, right? So I want to work on sparse structures rather than linear. I figured that word will slowly evolve to this, right? Word will evolve to this where they realize that this is a superior structure, superior data structure to implement things at. And I believe slowly we are moving there with folks like IOTA, Hedera.
That's what I was going to say. I haven't heard hash graphs and DAGs since reading like the IOTA white papers back in the day. This was, this is a throwback, because I mean, how much, like, why would you, because these IOTA's been around since how long? They launched way long ago, 2015, 2014. Like, why haven't these alternative data structures taken off? I mean, maybe Avalanche in a little bit of a way, but
I'll tell you. So when you attract economic value on something which is not that optimized, you try optimizing that rather than moving that economic value to something that's new. Happened with Nicholas Tesla.
sure. ACDC, yeah.
It moved us past by 40 years, almost 35, 40 years, right? So I believe the realization will occur. Teams like yours, mine, will start working on it. Then it's not that folks are not figuring it out, right? Now, folks are figuring it out, trying to build something. Even like when first you identify a problem, you identify that this thing is not scaling. You figure out scaling solutions like roll-up, CK, and all, right? But then you figure out that, okay, roll-ups are just optimizers, but this has a limit of optimization. So you figure out that something else has to capture that value. And trust me, if hash graphs are not able to capture the same value that Ethereum or Bitcoin did, it will never grow. It will not be reality. Even though it's fundamentally more advanced, it won't be reality. And just imagine if 10 years of research has been done on DAGs only. If the first principle of decentralization was DAG, where the landscape would have been, right? We could have thought, maybe we would have been talking about decentralized Gmail.
Sure.
Second big problem, right? Solving the data custody after money.
Yeah, well, I mean, it's always tough because, like, in theory, a lot of things work, and then, especially in the decentralized world, it's always hard
It's
to
like
see what
you have a value. In why hash graphs did not work, because they don't have a value.
Sure.
There's no value to be captured, no incentive to optimize. In blockchain, there are a shit ton of incentives to optimize. Like, it's where the money is. So that's why they are dying slowly. But I still believe, like, fundamentally those things are way more advanced. That's why you see it in almost every Web2, which started with linear structures, and then DAG came in existence to solve for scalability only, I believe.
Cool. And that's such a good take, as far such a good unexpected take to do it. Yeah, no, this was super fun. I definitely learned a lot. And how has been, I guess we'll be, where can people find out more about you? Where can people go to sort of, follow you on Twitter or website?
Twitter, you can look me on Twitter, on Route to page. You'll have the links. I can share it with you for sure.
Yeah, we'll definitely share it in the video chat. But thank you so much, and we'll talk to you soon.
Thank you, sir.